Alrighty, hello everyone, this is Mr. N. Here's the first video of hopefully many. We'll see how this works. I figure instead of giving you guys lessons every day using class time where you guys could be working together, I'm going to kind of give you more information as we're going through these concepts, and so hopefully with these videos you can have more resources in order to get that individual work done, understand the group work a little better, things like that. So let's start off with our first lesson of the year. Pretty standard. We're just going to talk about volumes of solids. So just as a review, we know that we can find the areas of certain shapes. So something like a square or a rectangle. Let's do a rectangle. A rectangle's area. Make sure we know what we're reviewing. We're going to have the length of our rectangle as well as the width. So we know that the area is equal to the length times the width. So notice how we're taking two dimensions of our two-dimensional object in order to find the area. So the area we can consider a two-dimensional analysis of space, of how much space something takes up. So we're talking about volumes now. We're really talking about how much space a three-dimensional object takes up. So we have many different ones. I'm going to look through each of them with you so we can kind of get an idea of where these concepts come from. So the first one we have is a prism. And that's general. It can be a cube, it can be a rectangular prism, it could even be a triangular prism if we wanted. So just to stick with the rectangle analogy, we're going to look at a rectangular prism. Looks a little bit like that. And we want to find the volume of it. Well, we know that the volume for a prism is always going to equal the base times the height. So in this case, we are going to need to find the area of the base as well as the area, as well as the height of this. So let's take a closer look at the base. If we wanted to look at the area of our base, we have to talk about the length times the width times the height. So our base is that length times width. It's establishing, okay, what is the two-dimensional cross-section of this thing, and then we're kind of multiplying it by that height. Okay? So if we wanted to just show our volume of our prism in terms of these three values, we'd have that it's the length times the width times the height. So I mean, you can throw in some values and you know, say the length is 1, the width is 1, the height is 1, each 1 meter, you would have a volume of 1 cubic meter. We can keep going, try something a little more difficult, something like this cylinder. Remember what a cylinder looks like. It's almost like we take a circle and we stretch it vertically. So it's going to look a little something like this. So here we have some values to find so that we can properly define what our cylinder volume is. So first is going to be the radius. We need the radius of the face of our circle in order to be able to calculate this volume, or how much space the cylinder takes up. The next component we're going to need is the height. So let's think about this intuitively. If we're talking about a prism in general being defined as the base times the height, if we can find the area of our cylinder's base, then we just have to multiply that by height. So if we're taking a look at our base, or we're looking at this cylinder head on, we're going to find that we actually have a circle. So if we're looking at the area of our circle with radius r, we know that that base, or the area, is going to be pi r squared. So we have that our area, or the base of the area, is equal to pi times that value r squared. So now we have the value of our base. Now we just need to multiply that by height. So the volume for a cylinder, and they call it V-sil just so that we can have it different from the volume of the prism. I'll even make that VP. The volume of our cylinder is actually going to be the area of the base times that little height. So it's going to be pi r squared times height. So we got 3 more to cover. We're going to take the pyramid now. So now for a pyramid, remember this pyramid could be a triangular pyramid or a rectangular pyramid, so you got to be careful. I'm going to do a rectangular pyramid, or where the base is a rectangle. And you'll see my badly drawn pyramid. The important part to know is that it's going to be, the volume for a general pyramid is going to be 1/3 times the base times our height. Actually, no, I'll bring it back to an inch. So, if we're looking specifically at a rectangular pyramid because the base is a rectangle, we're going to know that our base is just defined as the length times the width. So here we go again, length times width. When we're measuring the height, we want it perpendicular to the base, so we're not going to measure it as one of these tilted angles or these tilted slopes or sides. We want the shortest distance from the base to the tip of the cone. So that's going to be right here. So we can finally say our volume now, specifically for this rectangular pyramid, is length times width times height. And we want to make sure we include that 1/3 in the front as well. Times length times width times height. Okay? Alright, got 2 more for you guys. So these ones are really based off of this idea of a prism being equal to base times height, or a pyramid being 1/3 base times height, with the cylinder having that special base of a circle's area. So the next one to go through is the cone. So exactly like an ice cream cone. We know that we're going to have a top value as well, and it all just ends up at a point. So similar, I like to think of the cylinder as a special case of the prism. In the same way, I like to think of the cone in the same way as the pyramid. So notice how our volume is equal to base times height for the prism, whereas here it's 1/3 base times height. So for the cylinder and the cone, what you really just need to do is take the volume of your cylinder and multiply it by 1/3. So in this case, if we know that our radius is defined by this cross-sectional circle, and our height is defined from the base of the circle straight to the tip. Remember, we're not using our slants like in the same way we did our pyramid. Well, we know that the volume in this case is going to be equal to not pi r squared h, but 1/3 pi r squared times the height. So probably the most interesting, at least to me, the most interesting volume is that of the sphere. So the sphere is super interesting because there's really only one value or characteristic of a sphere that we need in order to define how much space it takes up. So we can draw out our sphere. It's got a little bit of a bulge, like so. And so for this one, all we need is that radius. From the very center of our circle, or our sphere, sorry, all the way out to the edge. So we'll just define that as r. So in this case, the sphere, the volume of the sphere, is equal to 4/3 times pi times r cubed. Okay? So that's all there really is to this first video, is just reviewing some good to know, some just good to know kind of formulas in order to find these volumes. Once again, the volume for a prism is base times height. Specifically for a rectangular prism, it's length times width times height. For a cylinder, we have pi times r squared times our height. And then over here for our pyramid, we have 1/3 times the length times the width times the height, or for a more general, base times height. For our cone, we have 1/3 pi r squared times height. And finally, for our sphere, we have 4/3 pi r cubed. Okay? So these things have, I mean, there's reasons why the volumes are these. We can actually start talking about that in terms of calculus as we get more and more knowledge about what integrals are, about what derivatives are, so that we can actually start coming up with these formulas from scratch. All right, so we have one more video coming up about finding equations of lines. This is to support you in your individual work, so I'll just cut it off now so we can go on to the next topic.